formulas. Let me review the formulas with you one more time here. A equals the principal 1 plus R over N to NT. N times per year. The interest is compounded. Accumulated value, principal, annual interest rate, and time is in years, and n times per year. The other one is P equals to RT. It's the same formula we've been playing with all night long. And this is for continuous compound interest. So this one is continuous. These are the two formulas. Okay, now let's see what they want. Suppose that you invest 5,000. So P is 5,000. So these are problems 10 and 11 on page 538. Okay. Which investment yields the greater return over 5 years? So T equals 5 years. 1.5% compounded semi-annually, which means N equals 2. This is one option. Or 1.45% continuously. Oh, compounded monthly, sorry. N equals 12. So which one is a better option for us? Okay, perfect. So here, the interest rate is 0.015. Here, the interest rate is 0.0145. So we repeat the formula, not continuous, but just the first one. For the first situation, A equals 5,000, 1 plus 0.015 divided by 2, to the power 2 times 5 years, 10, and we'll see what we get. And the other one is 5,000, 1 plus 0.145 divided by 12 to power 12 times 10 times 5 years, which is 60. Again, the principle is the same. N is different. Semi-annual is twice a year. Monthly is 12 times a year. T is the same, 5 years. So this power here is 2 times 5, or is 12 times 5. 2 times 5 will be 10. 2 times 5 is 60. And there are two different interest rates. 1.5%, I move the decimal digit 2 spots, 0.015. I move the decimal digit, 0.145. I'll put this in the calculator, and then this in the calculator, and then I'll say this is better or this is better to get more interest. Okay. So here I have no choice. I have to separate the two. I cannot put a function in for this situation. 0.15 divided by 2, and everything to power 10. And the other one is 5,000. And in parentheses, 1 plus 0.0145 divided by 12 this time. Close the parenthesis, and power, and this time is 60. So 5387, 5375, the first is a better option for us. So when it comes to money, 2 decimal digits are enough. 5387.91, 5375.73. So better. The first option is better. We get a little bit more money. by $12, roughly. Okay, the same question, but this time we have a principal of 14,000 and we invest over 10 years, compounded monthly, or 1.13% compounded continuously. These are totally different formulas. Monthly and continuously, as you saw, are two different situations. So in 11, we have the first situation. So P, 14,000. T is 10 years in both cases, of course. And R is 0.015 compounded monthly. And the other one is 0.0113 continuously. Okay. Good. This one, A equals 14,000, 1 plus the interest rate, 0.015 divided by 12, and 12 times 10 is 120. This one, A equals P, 14,000, times E to R, 0.0113 multiplied by the number of years, which is 10. So I'm determining this, and I'm determining this. Careful how you enter it in the graphing calculator, please. Okay, so let's take a look. So 14,000. Parentheses, 1 plus 0.015 divided by 12. Everything raised to power 120. No minuses. So 16,264.16. Now the continuously compounding interest, 14,000 times E, careful, I prefer parentheses, 0.0, you can multiply, but anyway, so let's do that since I started and close. So 0.0113 times 10, close the parenthesis, enter. So the second one is 15,674.85. Clearly, again, the first option is better for us than the second one. Better. It gives us more money.